is also 1 by 6. Okay. So that is how we have formed that we have stated the null hypothesis as the probability of getting a 6 is 1 by 6, like that we have stated the null hypothesis. Okay, probability of obtaining a 6 with the dice is 1 by 6, and then told you that we have to keep the null hypothesis in equals to form. That's why we are not going beyond our assumption, we are not going reverse of our assumption, rather we are directly stating that P is equals to 1 by 6. Okay. Alright, so till this much was done, and alternative hypothesis also we stated as P not equals to 1 by 6. So now we will test. We will test the null hypothesis and we'll decide what is correct, whether our null hypothesis is correct or our alternative hypothesis is correct. Okay. Now we have to calculate one small p. Okay, we have to calculate one small p that and we will calculate it with the help of the information given in our question. Now in our question it is given that out of 400 times the dice thrown, 800 times was 6, isn't it? So from here we will calculate the probability p. This is the actual p. Okay, so write down, since 6 occurred 80 times, write this line, since 6 occurred 80 times out of 400, write down please, since 6 occurred 80 times out of 400, since 6 occurred 80 times out of 400, since 6 occurred 80 times out of 400, comma, the observed value of the proportion P, the observed value of the proportion P, small p. This is called the observed value. Okay. The observed value of the proportion P of 6 is, small p of 6 is, that means the observed probability of the occurrence of 6 is small p equals to 80 by 400. This is the observed value of the proportion p, and we have assumed something. Okay, we have assumed something, that is our expectation, that is p naught, that is p naught. Now I am showing you the formula once. Okay, here small p minus capital P naught we have written. No, this small p can also be written as observed value, and this capital P naught can also be written as expected value. Okay, so how we are going? We are expecting that the value of p, small p, that means the probability of occurrence of 6 in the dice thrown is should be 1 by 6, so that we can prove that this is unbiased, right? But the observation says that it is 0.2. How have we calculated that? We have divided simply 80 by 400. Okay, 80 by 400 gives 0.2. Till this much, is it clear to all of you? Please tell me. We are expecting, I'm telling you again and then you tell me whether it is clear or not. Okay. Observed value is the actual value, okay, that has occurred. That means out of 400 times, if 80 times is 6, then what is the probability of occurrence of 6? It is 80 by 400. That is 0.2. This is the real value, okay. This is called the observed value, or you can also write it as small p. And our expectation is what? That the value of p should be 1 by 6. If it is 1 by 6, then we can say that the dice is unbiased. That's why our expectation is the value of p should be 1 by 6. Is it clear till this much? Please tell me.
Yes, ma'am.
Others? Is it clear to all of you? You people are writing or not? You should.
Ma'am,
Yes, tell me.
ma'am, this 80 by 400 is the original value.
Yeah.
Yes, ma'am. But then, like to prove that it is that the dice is showing the real result and it is
Huh.
unbiased, we
Huh.
have to see that P is 1 by 6.
Yes, that is our null hypothesis. We have assumed that, right? Now, with the
Hmm.
help of the formula, that is the formula of small z, we will see whether our assumption is correct or not. It's like that. Okay. Okay, now see, on the assumption, now write this line please. On the assumption that H naught is true, write down. On the assumption that H naught is true, so we will assume this, okay? So that we calculate the value of P naught. Since we have assumed that the value of P or in the null hypothesis you have written small p, you can also write capital P naught, no problem. So on the assumption that H naught is true, in bracket you write that is the dice is unbiased. On the assumption that H naught is true, in bracket write that is the dice is unbiased, bracket closed, comma, the expected value of the proportion, the expected value of the proportion, in bracket write P naught. Since we cannot write the same notation for both in our calculation purpose, that is why we are writing now it as P naught. Okay, so write the expected value of the proportion, in bracket write capital P naught of 6 is P naught equals to 1 by 6. That is our assumption, right? So we'll write P naught equals to 1 by 6. That is 0.167. That is 0.167. Okay. Now, if you have written the formula, I'm not showing you again. If you have written the formula which I told you to write yesterday, in the denominator it was standard error of P. Do you remember? It was standard error of P. Right? So we have to calculate the standard error of P. So the formula of standard error of P was root over PQ divided by N. Isn't it? Root over PQ divided by N. Now what is N? N is the sample size. Okay. N is the sample size. Now what is our sample size here in this problem? The dice has been thrown 400 times. So that is why our sample size is also 400, because this is the number of time the dice has been thrown. That is our number of sample. Okay, so denominator is 400. Now can anyone tell me that how the numerator is coming 1 by 6 and 5 by 6? How the value of P is 1 by 6? That I know, because you have assumed that P is 1 by 6. But how this Q value is coming as 5 by 6? Can anyone tell me? How this numerator portion value is coming as 5 by 6. 1 by 6 I know, but what is 5 by 6? Tell me.
It's 1 minus 1 by 6.
Yes, exactly. Who is this? Ayush.
Yes, ma'am.
Okay, very good, Ayush. This when you calculate Q, no, you have to calculate it by deducting the value of P from 1, because 1 is the total probability and P is the probability which you have assumed. So rest of the probability is your Q. That is why we can write somewhere Q, small q equals to 1 minus P. You can write somewhere small q equals to 1 minus P. Okay, so that is how we are getting the numerator as 1 by 6, that is the value of P, into 5 by 6, that is the value of Q, that is 1 minus P. So quickly solve this and tell me, are you getting this answer or not? 0.0186. Are you getting this answer or not? Tell me by calculating this. You can use the smartphone, there is root over, or you can use any calculator if you have. in order to calculate the root over value. Anyone completes, unmute and tell me, okay? Sheetal is present today. Sheetal. Sheetal not present. Okay, are you getting this value? 0.0186. Have you got this value? Check whether it is correct or not. Yes, tell me. Has anyone completed? Done. Have you got this answer? Tell me. Yes, anyone, please tell me. Have you got this answer or not? হ্যাঁ বন্ধ করে দিতে হবে। Yes, please tell me if you are finding any difficulty, if you are not able to understand, tell me. Don't sleep like this. Standard error. If it is 5 by 6, then you multiply it at 6. 5 by 36 it will be. Then in the denominator, root over of 400 means 20. So it will be 20. Then root over 5, bring that 6. Root, or you can calculate root over 5 by 6 is how much? If you have a smartphone or a calculator, calculate what is 5 by 6 answer. Then it will come in point. Then calculate the root over of that. And in the denominator, it will be 20. That is how you will get the answer. Ankita? Am I not audible? Ankita, Reena, tell me.
Yes, ma'am, you're audible.
So are you able to calculate? No one knows the calculation, how to do it. Okay, one of you unmute, please. Unmute. Please do it seriously. In your examination, if it comes, what are you going to do? At least one of you should understand so that you can copy. Yes, Ankita?
Yes, ma'am.
What are you saying?
Ma'am, you asked to unmute. Fine, unmute.
Yes, okay. Now calculate this one. Okay, calculate. Calculate this numerator portion. It is 5 by 6, isn't it? Numerator is 5 by 6. Sorry, 36. 5 by 36, right?
Yes, ma'am.
Numerator. Okay, now calculate 5 by 36. How much is it coming? Use your smartphone. All of you have smartphone. No, use your calculator option. You have root over out there.
Ma'am, it's ma'am, 5 by 36 is 0.1388.
0.1388. Okay. Now calculate the root over of it. 0.1388.
Ma'am, it's 0.373.
Okay, 0.373. That is the root over, right? And in the denominator, the root over of 400 is 20. So you divide that this value which you are saying 0.37 something by 20. You divide this.
Ma'am, 0.01865.
Okay, fine. So you got the answer. That is your answer. All of you, have you understood? Have you got? I don't have a blackboard or something to show you like this in online mode or the simple calculation, no? Simple calculation. Or what you can do is you can bring this 6 into 6, that is 6. Root over of 36 is 6 and root over of 400 is 20. So what you can do is you can bring this 1 6 in the denominator and multiply it with 20. Remove the root over. So it becomes root over 5 by 60, 6 into 20, that is 120. So that is how also you can calculate, or you can calculate in the way which Ankita helped me to calculate. Have you understood? Is it clear to all of you? Ankita understood. Others?
Yes, ma'am.
Okay. Pratiksha?
Yes,
Are
ma'am.
you-
I got it. I got it right now.
Okay. Okay. Mute. Ankita, mute. Rajeshwari, are you doing? Rajeshwari, Shruti,
Ma'am,
are you doing? Have you got this answer?
ma'am, doing.
This calculation have you done?
No, no, ma'am, I'm doing it.
Okay, do it. Have you understood how to do this?
Yes, ma'am.
Yeah, do it. Once all of you finish, then I'll move ahead. Ayush, have you understood?
Yes, ma'am.
One way is simply in order to avoid confusion, in order to avoid mistake, what you can do, you can simply calculate the root over of 5 by 36 using your smartphone, and in the denominator you can calculate root over of 400. So you'll get 20. So whatever value you get in the denominator and numerator, just simply divide the numerator by the denominator. Like that you will get 0.0186. Okay, those who have finished, they move ahead, and those who haven't finished, keep it. You can do it after the class. Since you have understood, you're saying you have understood, so you can do it after the class also. Okay, because I have to finish this sum today. Okay. So now next line you write, our test statistic is, no need to write using the proportion of 6 in the sample. Just write our test statistic is, write down our test statistic is Z, small z equals to, this is the formula, okay? You can also write small p minus p naught, or you can also write observed value minus expected value. Write down. Our test statistic is small z equals to observed value minus expected value divided by the standard error. Observed value minus expected value divided by standard error. So now substitute the values. Observed value is this small p, that is 0.2, and the expected value will be the p naught, that is 0.167. Divide it by the standard error which you have calculated right now, that is 0.0186, and get the answer as, and see whether you're getting the answer as 1.77. 1.77. Are you getting this answer? This is a simple calculation. Do it and tell me.
Yes, ma'am.
Okay. Others? Just one or two of you tell me whether you have got this answer. Have you got this answer? Tell me. 1.77. Okay, I'm assuming you have got this because this is not a very tough calculation. Just subtract in the numerator and whatever you're getting, divide it by 0.0186. Okay, now I will take you to that table. Now all of you look at the screen please. This table, we are doing this first one, no, where we are assuming one null hypothesis as equals to and null alternative hypothesis as not equals to. So we're doing the first thing. First row we are doing, isn't it? P naught equals to P naught. So here, if this this z is the tabulated z, okay, sorry, the calculated z, if it is greater or equals to 1.96, then we reject. Am I correct? This is the rejection rule for H naught. This table for 14.4 is the rejection rule of H naught. So if this calculated value of z is greater or equals to 1.96, then we reject the null hypothesis. Now tell me, you have got the value of z as 1.77. So will you reject the null hypothesis or accept the null hypothesis? Tell me. The rule is, again I am telling, now I want this answer. The rule is, if this calculated value of z is greater or equals to 1.96, then we reject the null hypothesis. Now you are getting 1.77. So tell me whether you will reject the null hypothesis or accept the null hypothesis. Tell me.
Ma'am, we'll accept the
Accept. Very good.
yes, ma'am,
Why we
because
are
it is
accepting?
less.
Less.
Because it is
Exactly.
less than 1.96.
Exactly, very good. So Pratiksha has given the right answer according to her, and it is correct also, that since this calculated value of z is 1.77, which is less than 1.96, if had it been greater or equals to 1.96, we would have reject the null hypothesis. But since it is less, so what will you write? You will write from this line, since the value of z does not fall in the critical region, in bracket you will write quickly, write this line, from since you will write, from since you write, okay, right, since the value of z does not fall in the critical region, in bracket you will write critical region at 5% level, z mod z is greater or equals to 1.96 comma, it is not significant at 5% level. We have therefore no reject the null hypothesis. Or you can write this line properly, this is grammatically error. You write, therefore, we do not reject the null hypothesis and call, therefore we accept the null hypothesis. You write, therefore we accept the null hypothesis and conclude that the dice is unbiased, because why? Our null hypothesis was what? That the dice is unbiased, isn't it? That's why when we are accepting the null hypothesis, that means it also proves that the dice is unbiased. Write down these lines. Since last line you write on your own. What I said, you write that. Ankita, Pratiksha, Ayush. Ankita, Ayush. Bikram present. Okay. I'm giving you attendance. By that time you write. Yes, have you written? Have you finished writing? If you have finished, tell me what you have written. Pratiksha, have you completed?
Yes, ma'am.
Okay, tell me what you have written.
Ma'am, since the value of z does not fall in the critical region, we have written that the critical region at 5% level, 1 is greater than equals to 1.96. Therefore, we pass the accept the null hypothesis and conclude that the dice may be unbiased.
Okay, very good. Very good. This is how you write, okay? This is the these are the lines that you should write. Okay. So, shall I share this PDF file with you in the group so that those who have missed, those who could not write, they can also write? Shall I share this PDF file in the
Yes,
group?
ma'am.
Okay. So I'm sharing this PDF file. Those who missed, you should finish this sum today itself, okay? So that we can move ahead with the next sum tomorrow. So please finish this today, those who could not finish. And if anything is understandable, you can always text me, okay? You all have my WhatsApp number. You all can message me that, ma'am, this part I did not understand. This one I will explain, okay? This is how we can communicate easily. Okay, so you please complete this sum so that we can do the next sum tomorrow. All right, I have given your attendance. You can leave the class. And anything you want to ask, you can ask.